In today's session, I am going to discuss about three important factors. They are EMF, potential difference, and internal resistance. Yes, EMF of a cell, potential difference across a cell, internal resistance of a cell. Fine. As all of us know that a chemical shell is a device which converts the chemical energy into electrical energy. We have a power shell here. Okay. It is a portable form of Lachlan cell whose EMF is 1.5 volt. Okay. Which converts the chemical energy into electrical energy. This power shell, this chemical shell is not rechargeable. Once its energy is exhausted, it has to be thrown out. So it is not a rechargeable shell. But there are cells, they are known as secondary cells like lead accumulator. Car battery is a rechargeable cell. Fine. Here we do have digital Daniell shell and we have digital Lachlan cell. The EMF of this cell is, that is Daniell cell, is 1.08 volt, whereas the EMF of Lachlan cell is 1.46 volt. Okay. The EMF or the potential difference can be measured using a multimeter. This device is known as multimeter. From this device, we can measure the potential difference across 2 points, or the EMF of a shell, or we can measure the flow of current through a circuit, or we can measure the resistance of a resistor connected in a circuit. So this device is known as multimeter. Here we use this multimeter to measure the EMF of a shell or the potential difference across 2 points in a circuit. Fine. Let us define what is EMF. The expansion, the elaboration of EMF means electromotive force. It is basically a chemical force which exerts on the ions to move in a circuit. It is a chemical force which exerts force on the ions to move in an electrolytic cell. Why? So, if you consider a chemical shell, it is a chemical shell. If there are 2 or more number of shells connected in series, then it is called a battery. Battery is a combination of several cells. Here, if you take that power shell whose EMF is 1.5 volt, here it is 1.5 volt plus 1.5 volt, it is 3 volt. If the cells are connected in reverse order like this, then the net EMF of the cell is 0, because here they are connected in the opposite direction. Here the negative terminal of one cell is connected to the positive terminal of the other cell. The cells are in series and the EMFs are added here. The total EMF would be E1 plus E2. Here the total EMF would be E1 minus E2. E1 is EMF of the first cell. E2 is EMF of the second cell. Okay, let us try to define what is EMF. Okay, it is the difference in potentials between the two terminals of a cell. I repeat, it is the difference in potentials between the two terminals of a cell when no current is drawn from the cell. In other words, it is the difference in potentials between the two terminals of a cell when the cell is in open circuit. It means no current is drawn from the cell. This gives us the EMF of the shell. Okay, what is potential difference? Potential difference is the difference in potentials between the two terminals of a cell when current is drawn from it. In other words, potential difference is the difference in potentials between the two terminals of a cell when the cell is in closed circuit. Here from the cell, current is drawn by the resistor. Here from the cell, no current is drawn from the resistor. Here it gives EMF. Here it gives potential difference. Here the cell is in closed circuit. Here the cell is in open circuit. So it's very clear. EMF of a shell is the difference in potentials between the two terminals of a cell when the cell is in open circuit. Potential difference is the difference in potentials between the two terminals of a cell when the cell is in closed circuit. Fine. How do we write EMF of a shell? How do we write EMF of a shell? EMF of a shell E is equal to the potential difference across the resistor. E is equal to V. And this cell has some internal resistance, that is R. R is the internal resistance of the cell. The internal resistance of the cell depends on the electrolytic substance and the surface area of the electrodes, the positive electrode and the negative electrode. Fine. What is that internal resistance? It is the resistance of the electrolyte by which it opposes the flow of ions. Internal resistance is the opposition offered by the cell itself to the flow of ions. And this internal resistance, it depends on the nature of the electrolytic substance and the area, the surface area of the electrodes. Right? Here, the EMF of the shell E is equal to the potential difference across this resistor plus the potential difference across this resistor. So this V plus V dash is equal to E. This is V dash. What is V dash? The potential difference across the internal resistance of the cell. It is in the cell. It can be shown like this also. So this V plus this V dash is equal to E. How do we write that E? E we write as E is equal to V means according to Ohm's law, the current into resistance. This is current I. Current is drawn from the cell by the resistor. So E is equal to IR. Here the potential difference is V is equal to IR. Here the potential difference is IR. Current into resistance. So current into resistance. So we can write that E is equal to I is common R plus R. and the current that is flowing through this closed circuit, I is equal to E divided by R plus R. Here, the cell is under discharging action. Cell is sending the current, and the current is drawn by the resistor from the cell. So, the total current that is flowing through this resistor is equal to the total voltage of the cell divided by the total resistance. So, this equation, when the cell is under discharging action. Okay, if the cell is under charging, say for example, when we keep a rechargeable cell, lead accumulator for charging, just like whenever the car battery is exhausted, its potential difference, we keep the car battery for charging. The circuit will be like this. This is the battery and this is the resistor, and this is the internal resistance, this is the external resistance. This is connected to safeguard the battery, and here it is under charging. Here is the potential difference, the DC voltage that we have given. The cell is under charging, the battery is under charging. This is the situation of rechargeable battery. Here, EMF is less than the applied voltage. The cell is charging. This is the source of electricity, a socket. For a socket, we have put this plug. Okay, so in that case, the supplying voltage is more than the EMF of the battery, E plus IR. This equation is when the cell is under charging. This equation or the other equation also we can write E is equal to V plus IR. V plus IR. This is when the cell is under discharging. When the cell is under using. This is when the cell is under charging. Okay, so here this is all about EMF of the cell and the potential difference. It's very clear that the EMF of the cell is the difference in potentials between the two terminals, positive and negative. EMF of a cell is the difference in potentials between the two terminals of a cell when no current is drawn by the cell. Potential difference is the difference in potentials between the two terminals of a cell when the current is drawn by the cell. Whenever the cell is under discharging, EMF is greater than the potential difference. Whenever the cell is under charging, EMF of the cell is less than the potential difference. So these factors are very important. Then what is internal resistance? As I have told you that it is the opposition offered by the electrolyte to the flow of ions. And internal resistance of the cell, it depends on the nature of the electrode and the surface area of the electrodes. It depends on the nature of the electrolytic substance and the nature of the electrodes or the surface area of the electrodes. Fine. How do we calculate internal resistance? As we know that E is equal to, when the cell is under discharging, E is equal to V plus IR, or IR is equal to E minus V. and divide this equation by V. IR by V is equal to E minus V by V. What is V? V is known as potential difference according to Ohm's law. It is I into R, which is equal to E minus V by V. I cancels. What we get is the internal resistance of the cell is equal to R in the bracket E minus V by V. Yes, R is this external resistor and E is the EMF of the shell and V is the potential difference across the resistor when the current is drawn by the resistor. So this completes the difference between EMF of the cell, potential difference and the internal resistance. EMF of the shell is in volts, potential difference is in volts and internal resistance is in ohms. So when this dynamic shell or the Lackland cell, when they are not connected in circuit, so whatever the difference in potentials between these two terminals is there, that is EMF of the shell. So that we can measure by connecting to a multimeter. This gives the EMF of the shell. When this cell is connected in the circuit, if you connect here the multimeter, so that time it gives potential difference when this cell is connected in the circuit. When the cell is in the open circuit, it gives EMF. When this cell is in the closed circuit, it gives potential difference. Fine. Thank you.